This movie is for modeling different situations, and this is the lesson part, which will be in the form of a movie. And after this, you will be expected to complete the worksheet, and at the top it says Modeling SLO Worksheet. So you don't need to know what SLO stands for, you just need to know that this is about modeling situations in geometry. And so these problems come exactly from the worksheet. So I'm basically going through a few of the problems on the worksheet. So you'll probably want to write down as we go, or pull up the worksheet and go ahead and label these problems as we go. Mathematical modeling it goes along the lines, when in doubt, draw it out. So you're modeling different situations to help you arrive at a solution. For our situation, we're going to draw it out and then represent each problem with a model, then solve. So you're expected to show a model of the situation, then solve it. Given line segment AB with a midpoint at -624 and endpoint A at 12, -12, find the endpoint B. So the first thing we want to do to model this situation, and this goes with number 1 on that worksheet, is to draw AB with a midpoint M. So what we're going to do first is go ahead and draw AB. We've got a midpoint here at -624. A I've labeled as 12, -12, and B I've labeled it as XY because I don't know what the values are for point B. Now that I have my model, I can see that I need to solve for this. Knowing that this is a midpoint, I can use my midpoint formula, x1, 12, plus x2, x, divided by 2 should give me -6. So if I'm solving for the x's, I get 12 plus x divided by 2 gives me -6. Multiply by 2 and then subtract 12, I get that x is -24. Another way to do that is to think, what did I do to 12 to get -6? And then what would I need to do to -6? I'd do that same thing to get what my x value is. So you can see here is I've subtracted 18, and then I have to also subtract 18 here to get -24. To get the y value, I'd go -12 plus y divided by 2 gives me 24, because this is my new y, my midpoint y. Well, here I multiply both sides by 2, and I get -12 plus y equals 48. Then I add 12 and I get y is 60. So I can tell that y is 60 by using the midpoint formula, or I can think, what do I do to -12 to get 24, and do that same thing to 24 to give me the y. So you can either pause the movie now and do those first 3 problems on the worksheet, or you can keep playing through all the different types of problems and then work on the worksheet. So 2 and 3 are similar to 1. I'm going to go to number 4 and help you work on number 4. It says angle ABC and angle CBD are supplementary angles. So I could draw a straight line with these. Notice they have some points in common, B and B. Measure of angle ABC is 4x plus 6 and CBD is 11x minus 6. What is angle ABC? So we're going to draw out this situation to start off with. Here I've got ABC and CBD. Notice CB is common in both, so I know it's sharing that ray. So I can set them up so they form a straight line because they are supplementary, and I know now that these two added together will give me 180. So I add them together, set it equal to 180, I add my like terms, and then 6 plus -6 is 0, so I get 15x equals 180, x must be 12. But the question says, what is the measure of angle ABC? So I know ABC is going to be 4 times 12 plus 6, which is 54 degrees. You can pause the movie and try the next few problems, or keep playing the movie and go to the next example, which is number 7. So we're going to look at some algebra here. I've got the measure of angle OZP is 4r plus 2, PZQ is 5r minus 12, and OZQ is 125. What are the measures of OZP and PZQ? This gets really confusing because of all the letters. But if we organize the situation where I've got OZP, then when I see PZQ, I know I've got PZ right here, so they're sharing the same ray. PZQ, I'll just attach it because they share PZ. That is in common in both. Then here when it says OZQ, I can see that it's talking about that entire angle, the larger angle. So I know if I take these two smaller ones and I add them together, I'll get the larger angle. So I do this, I add them together, set them equal to 125. I simplify and solve 2 plus negative 12, negative 10. I add 10 to both sides and divide by 9. I get R is 15. It's asking for the two angle measures, so I got to plug it back in to my 4R plus 2 and to my 5R minus 12. And I get 62 and 63 degrees. So be careful on these next few problems to make sure you draw it out correctly. Or you can keep playing the movie and then go to the worksheet. Number 10 is our next problem. Given point B on line segment AC, if AC is 62, AB is 2x plus 8, and BC is 3x minus 1, what is x? So when in doubt, draw it out. We're going to draw out the situation. I've got AC. Point B is lying on the line AC. AC is 62, so I have the length here labeled as 62. AB is 2x plus 8, and BC is 3x minus 1. What is x? Well, I can see here that if I take the sum of each of these, put them together, I should get 62. So my equation becomes 2x plus 8 added to 3x minus 1 equals 62. I simplify and solve. I subtract 7, divide by 5, and I get that x is 11. In this case, I'm just asking for what x is, so I put 11 and then move on. So you can try the next few problems and then press play when you're ready, or just keep watching the movie. Again, modeling the situation before we go to solve it. Let's look at 12. Given triangle ABC is congruent to triangle XYZ, you can see that we can go ahead and draw that out. We're given AB is 5x minus 1, XY is 2x plus 29. Find the length of AB and XY. So let's draw out the two triangles, ABC, XYZ, then modeling the situation. Then I'm going to label AB as 5x minus 1, XY is 2x plus 29, and because the two triangles are congruent, I know these two sides must be equal. So I set them equal to each other, and I subtract 2x on both sides, I add 1 to both sides, then I divide by 3, and I get x is 10. However, oops, it says to find the length of AB and XY, so I got to plug 10 back in. Let's plug 10 back in. So I get 5 times 10, 50 minus 1. So I get 49 here. Let's see if I can write 49. AB is 49 when I plug it back in. And then here I get 2 times 10, 20, plus 9 gives me 49. So I can see that they're both congruent, and that should make sense because my two triangles are congruent. We're going to move on to 14. You can pause the movie and try the next few, or just move on to 14 and then go back to the worksheet to complete all the problems. But we're going to look at this triangle, and we're going to determine if we have scalene, isosceles, or equilateral. Some variation to this would be if you were given the endpoints of the triangle and you had to draw out the triangle to model the situation. Looking at this triangle, we're going to find the length of each side. So if I want to find xy, I went down 4 to the right 2, so I do the Pythagorean theorem, 4 squared plus 2 squared. I get 16 plus 4, that's 20. Square root of 20. So I know xy is square root of 20. Zy, I can see I go down 2 to the right 4, so that's also 4 squared plus 2 squared. So I know zy is going to be square root of 20. Then if I do zx, I went up 2 to the right 6, 2 squared plus 6 squared gives me 40. So I know that zx is square root of 40. So this triangle is isosceles since two of the sides are congruent. Again, modeling the situation with the different learning targets we've had this year. You can pause the movie, try the next few, or just keep playing. This guy is number 16. And it says, are the polygons similar? If they are, write a similarity statement and give the similarity ratio. In triangle QRS, QR is 4, RS is 15, measure of angle R is 36. In UVT, VT is 8, TU is 32, and T is 36. So we've got to draw out this situation. I've got QRS, UVT. I've got 36 here for R, 36 here for T, and I plugged in my values. And you can see for similar polygons, it looks like I'm trying to get side, angle, side. My angles are congruent, but I have to still see if my sides are proportional. I can see here that I did 4 times 2 to get 8, but 15 times 2 is not 32. So 4 eighths is not equal to 15 over 32, so the sides are not proportional. So these would have to be no, triangles not similar. You can try the next few or keep playing the movie. We're going to go to number 18 now. It says a kite with a string of 150 feet long makes an angle of 45 degrees with the ground. Assuming the string is straight, how high is the kite? I would like you guys to model this situation and then we'll solve it. So we've got to model the picture. We've got a kite in the air. It's X off the ground. It's a 150 feet long string and it's making a 45-degree angle here. So I know that this guy is a right triangle. This is a right angle. So knowing that he's a right angle, I'm going to put him in as a right angle. And this only works if you've completed unit number 8. If you've completed unit number 8 and taken the summative, you can do this. So I know 45 is here. This would have to be 45. I've got the sine because the opposite is what I want to find and the hypotenuse is what I'm given. So I'm going to use the sine function. The sine of 45 equals the opposite x over the hypotenuse 150. To solve this equation, I'm going to multiply both sides by 150. And I get that x is 106.1 feet. So that's how high the kite is. That's all for this movie. You've now seen how to model these different situations. I would like you to take this theme and you are to complete the worksheet, Modeling SLO Worksheet. We've done a few problems in this movie. Please finish that worksheet.